In problem number 12, we've got a normal distribution with a mean of 125 and a standard deviation of 4.2. So let's go ahead and write this out. We've got x is normally distributed with a mean of 125 and a variance of 4.2 squared. Now, in part 1, it says find the probability that a random chosen bar of soap weighs more than 128 grams. So that looks like this, and we're going to convert it to a z-score using the z-score formula. It's going to be 128 minus 125 over 4.2. And then when we go ahead and get that, we get 0.714. We rewrite it as a z-score, so now we're doing the probability that z is greater than 0.714. And keep in mind, we want our z-score to be positive, but we also want it to be less than. So if you draw this picture, you'll see that what happens is that we've got the z-score, mean is 0, and our z-score is right here roughly, and this is the probability above it. Well, obviously, if I take the probability below it and subtract it from 1, it's going to equal the area that I really want. So that's what I'm going to do, because that's going to enable me to do less than and with this positive z-score. At any rate, when I go to the calculator and inverse normal, the lower boundary is going to be negative 9 times 10 to the 99, and the upper boundary is going to be 0.714. And then I leave the standard deviation and mean the same, and I find out that I get a probability of 1 minus 0.76238, blah, blah, blah. And when I subtract that from 1, I can store it into x, and then go back to the main menu, the calculation menu, and do 1 minus x, and that gives me this to save me from retyping the whole thing. I find out the probability is going to be 0.238. Now in part 2, it says find the value of k such that the probability that x is less than 128 and greater than k is equal to 0.7465. So we've looked at problems like this before. Basically, let's draw a quick picture. We've got a normal distribution. We don't know what the mean is, but we do know that 128 is probably over here somewhere. And we do know that k is going to be less than that, so that's going to be over here. And we do know that the area between them is 0.7465. Now, the way to go about this problem is, keep in mind, we're going to need to know this area that's to the left of k. What we're going to do is that we're going to write a probability statement saying the probability of x being less than k is something, and then we can go ahead and use inverse normal to figure it out. So if I take the probability of its being less than 128, that's going to give me everything that's below 128. And then all I've got to do is subtract the 0.7465 from it, and that'll give me that little area down there in the corner. So we've already done this 128 z-score, and we know it's 0.714. So all we've got to do is use that again. And the probability is the same. We've already figured that out. So now all I'm going to do is subtract the 0.7465, and I'm going to get 0.015886, and that's that little space over there. And so now what I'm going to do is I'm going to write my probability statement. The probability that x is less than k is going to equal 0.01588641. And now I'm going to change these into z-scores, so it's going to be k minus 125 over 4.2. And then the z-score that matches up with this, it's obviously going to be negative because it's way over here on this side, but we're going to do inverse normal, and we're going to put in 0.015 blah, blah, blah. And we're going to find out that that value should be a negative 2.147. And so now, all I got to do is get the k by itself, and I'm going to find out that k is equal to 115.9826 or 116. And then when you go to part 3, it says 5 bars of soap are chosen at random. Find the probability that more than 2 bars each weigh more than 128 grams. All right, they're switching gears on us. Notice the 5 bars. That's trials. We're looking at each bar and we're seeking to see whether it weighs more than 128 grams. It's either going to be yes or no. This is 2 possible outcomes. This is a binomial distribution. The probability, we're going to assume, is constant, and so if I write this as a binomial distribution, I'm going to have 5 trials, and I need to know the probability of it being more than 128 grams. Well, we already figured that out. That's this right here. The probability of it being more than 128 grams, that's this, which we rewrote into this, and we found out that it was this. So that's our probability that we're going to use. And so let's put that over here. And see, we've got choices. What we're going to do is we're going to find the probability that x is more than 2 bars. That's greater than 2 bars. So what we can do is we can find 1 minus the probability that x is equal to 0, 1, and 2. Or we could find the probability that x is equal to 3, 4, and 5. It doesn't make a difference. In both cases, you're going to have to do 3 things. We set up our binomial distribution. We've got our combination. Here's a probability of success. Here's our probability of failure. The first one's going to be the 0 power. The next one's going to be the 5th power. I'm going to quickly go ahead and write the other 2. And I'm not going to multiply this in the calculator. I'm just going to write this down to show my method. And then at the bottom, I'm going to write 1 minus. So after I get my 3 answers, I don't forget to subtract them from 1. Binomial, okay, and you're going to do a list, and I'm going to do 0, 1, and 2. The probability is, our trials is 5. Our probability of success is 0.23761. And now I'm going to copy these down, one at a time, and then add them up. After I add them up, I'm going to subtract them from 1, and I'm going to get my answer. Now, after doing this problem and checking in the back of the book, the answer doesn't match exactly. It's off by a little bit. So I went and looked it up in the other test, in the actual test itself, and looked in the rubric. And what I found out was that we should be actually rounding z-scores to 4 places, not to 3. So do me a favor, I'm not going to redo this video, but in the future, when you're doing your problems, round your z-scores to 4 places instead of 3 like I told you. All right, thanks.